Look closely at this cargo ship. It is sailing on a canal that sits directly above a busy modern highway. 26% of the Netherlands exists below sea level, leaving the nation sitting in a geographical bowl while the ocean looms several meters overhead. Early Dutch settlers manufactured the ground beneath their feet. By building ring dikes around swamps and lakes, they pumped the water out to expose the seabed, creating dry plots of land known as polders. But extracting that water triggered a massive problem. The dry clay soil compacted and shrank. The more they drained the water to stay dry, the deeper the ground sank below the surface of the ocean. By the mid-20th century, millions of people were living in a highly precarious state, relying on a patchwork of traditional earthen dikes to hold back the immense weight of the North Sea. This geography is a human product. Centuries of relentless terraforming engineered a landscape that required constant, flawless defense to remain dry. On the night of January 31, 1953, a violent storm funneled directly into the North Sea, pushing a massive wall of water against the Dutch coast, just as the spring tide reached peak. While the country slept, the dikes gave way. The freezing ocean violently reclaimed 150,000 hectares of land in a single night. 1,836 people lost their lives before sunrise. The rescue efforts required immediate, desperate improvisation. In one municipality, a mayor ordered a local captain to ram his heavy river freight ship directly into a collapsing dike, successfully plugging a critical breach. In the aftermath, the Dutch government issued an absolute mandate. This would never happen again. They formed the Delta Committee with the objective to permanently shorten the national coastline by 700 kilometers. Passive defense was no longer an option. The Netherlands launched a highly coordinated engineering war against the ocean, moving from reactive repair to a strategy of active, massive-scale prevention. The first major challenge was the Eastern Scheldt estuary. Engineers initially planned to build a solid dam across the water, but sealing the inlet completely would destroy the region's massive fishing industry and its fragile saltwater ecosystem. The solution was a 9-kilometer movable storm surge barrier. It allows tides to flow naturally under normal conditions, but can be entirely sealed when extreme weather approaches. Building it meant conquering fast-moving tidal currents. Using custom-built ships, crews lowered 5,500-ton concrete mattresses to the seafloor with millimeter accuracy. Between those piers, they suspended 62 massive steel gates, each 42 meters wide, ready to drop at a moment's notice. The Eastern Scheldt project proved that large-scale hydraulic defenses could be precisely engineered to adapt to complex ecological demands rather than just overriding them. Protecting Rotterdam required an even more specialized approach. As Europe's busiest port, the local economy relied on massive cargo vessels passing through daily, meaning the shipping lanes could not be permanently dammed or restricted. To solve this, engineers built the Maesland barrier. 2 curved steel gates, each 210 meters long, rest on dry land and swing out over the water only when a severe storm is imminent. Holding back the North Sea's force is a massive mechanical challenge. The load is channeled through 2 ball and socket joints, each 10 meters across. When deployed, the hollow gates float out, flood their interior chambers, and sink to the riverbed, creating an impenetrable seal. Because a sudden storm surge could trap or delay human operators, there is no manual button. An automated computer system continually monitors sea levels and independently triggers the closure sequence. These megastructures shifted hydraulic engineering from a vocational craft to a science-based enterprise, utilizing probabilistic models to maintain a high-tech fortress around the nation. But a new threat is altering the baseline parameters those barriers were designed for. Rising global sea levels are pushing the deltaworks to their physical limits. Simply building higher and thicker concrete walls, a strategy known as hard engineering, is reaching its limit as a sustainable solution to rising tides. The strategy has shifted towards soft engineering. One example is the sand motor, where engineers intentionally dumped 21.5 million cubic meters of sand onto the coastline in a single massive pile. Instead of dredging every few years, they rely on the ocean's own wave energy to distribute that sand over 2 decades, letting nature fortify the coastline for free. Inland, the complementary Room for the River project takes a similar approach. Engineers are removing older barriers and widening floodplains to give surging water a safe place to flow. Long-term resilience requires accepting that water cannot always be repelled with force. Sometimes it must be strategically accommodated. Now, other major global cities are discovering the same sudden vulnerabilities the Dutch faced back in 1953. In response, the Netherlands is turning climate adaptation into its greatest export. Dutch engineers are consulting on massive global projects, like New York's Big U, to help protect vulnerable coastlines worldwide. The effectiveness of these defenses depends on a unified legal, political, and cultural mindset regarding water issues. The physical infrastructure is the direct result of a 1,000-year-old system of communal water management. Humanity's survival on a warming planet depends on learning the Dutch lesson. We have to stop fighting the ocean and start designing alongside it.